Now the next topic is on a totally different environment. It is about innovation and hybrid propulsion and various projects we are working on at the moment. Manfred Rachel, who is one of our pioneers in the domain, is working a lot since years. He started almost alone. Now there is a complete stream in the agency. You are still smiling, Manfred, so thanks a lot. Manfred will introduce you to what we are doing here, but just a word of introduction. Yesterday you were presented with a number of ideas, concepts, new developments. In the agency, we really want to develop new activities to follow your development, new technologies, innovation. We are creating new streams in the agency. You will see in the very near future some new changes into the organization, specifically targeting a more efficient, or let's say a better daily direct involvement into innovation and special activities. What we have today, Patrick Key created earlier this year what we call the Innovation Cell, who is really coordinating at the agency level all innovative, let's say, activities. We are creating inside the agency an innovation network with all kinds of experts and non-expert project managers and so forth registered. And we really want to develop this kind of community identity within the agency to have not only the historical safety regulator with CSCs, etc., working into a comfort zone very well established, but also to have an agency looking forward, preparing the future, and trying to support you as best as we can on new developments. Hybrid propulsion, electric propulsion is one of the most obvious ones, together with drone, hyperpets, and so forth. But we have also plenty of other ideas on how to work with you as partners onto these innovative programs. It is a new mindset. You may not be used to it, having an authority working with you as partners on developing concept, feasibility studies, etc. That means trying to anticipate what you do to be able to work with you as a regulator later, having knowledge and expertise in what you are doing. But today, I think I will stop here, Manfred, because I don't want to spend all of your time. But today, what we need to let you know is where are we into the electric and hybrid propulsion and a few other things. I'm sure, Manfred, there's a lot of interesting topics for you. Thanks, Manfred.
Well, yeah, good morning to everybody. My name is Manfred Reichel. I'm section manager in the GA department for the CS-23 aircraft, all with piston. And it's a pleasure for me to guide you a little bit through the future, or already to what happened now, the electric and hybrid aviation project. And as Alain was saying already, also about certain possibilities we have with an innovation cell and tech and this kind of things. So let's start right away. Currently, you see everywhere on the world development ongoing on the e-aircraft. E-aircraft really means everything from, I don't know whether you know it, the Blackfly, which is a nice single-seat have-to-have or want-to-have gadget, all the way up to the bigger airplanes. Here is a very, very small selection you can see worldwide and where it's from. Interesting is here the development of the e-aircraft, where it happens really. So you find about 36% is in the US, and in Europe it's actually 34%. So those are the data from about 4 months ago. Of course, it changes every day because there are new projects coming and some are going. But it's quite interesting. And Asia, of course, with currently 20%, is coming as well. If we look into internet, purely Europe, so we have, for example, the Extra with electric power, and they can fly with the batteries. They have on board a complete program, aerobatic program. We have the Thales Stratobus. We have the E-Fan, Daher Sokata and Airbus. We have Pipistrel, which is a conventional aircraft with batteries and electric motor on board. We have things like Pop-Up coming from Airbus as well. An aircraft which is existing already quite a while is the Lange Antares. This is flying since several years by now, electric. Then Rolls-Royce, the electric fans. Lilium, which is currently going throughout the press. The same with the Volocopter. And even the big boys, again, Airbus has some studies ongoing with a very strange aircraft with a completely different kind of propulsion and aerodynamics. And then we have research ongoing under the Horizon 2020 within the European Commission, where it's funded. So what you see here is really an overview of all the different kind of things, from vertical takeoff to conventional aircraft. The Stratobus is with, as you can see on the picture, with solar panels, and it goes all the way up to 20 kilometers and all this kind of things. So it's very, very interesting and very innovative. This brings new philosophies, of course. For the conventional aircraft, more electric aircraft. So getting rid of hydraulic systems, installing more and more electric system. Electric taxiing, spool up using the engine. Most of you, or at least some of you, know the 7 seconds requirement. For a turbine, you have the power available for a go-around, which you can reach after 7 seconds after you pushed in the throttle. And with electric motor, the spool up can go faster, so you have more power available for go-around, while for the flight idle, you can reduce further. Then, of course, we have the hybrid propulsion, all-electric aircraft, and for the new designs, basic layout, distributed propulsion influencing boundary layer, and the electric VTOL. Especially for the hybrid, it's always the question. A lot of people say, well, this doesn't work because you do nothing else but putting together the efficiency, the low efficiency of the combustion engine and the quite good efficiency of the electric motor. And in total, this makes even less efficiency. True. Absolutely true. But with the electric motor, suddenly you can do a lot which is not possible so far. So especially the distributed propulsion, as you could see on the one big airplane with the 6 fans in the back, there you have a big potential to really gain efficiency, to reduce the boundary layer, to make it thinner, and by that reducing the drag. NASA has done a study where they found with a single electric fan at the end of the aircraft, you can reduce the fuel consumption of more than 17% just by doing this. Well, of course, this implies also new technology, like new battery types, fuel cells, solar panels, increasing voltage, if we talk about high voltage. And for motor manufacturers like Siemens, high voltage is different to our high voltage. We are talking about 270 volts, 500 volts, up to 5,000 volts. For us, this is really high voltage. For them, this is low voltage, but anyway. So there is knowledge available already in this way. Also, the propulsion systems are changed. The brushless high power motors are coming more and more. And if you see the size of the electric motors and the power they have, it's really amazing. It's 1 to 6, the ratio from the weight to the power. Electric fans, power reserve for helicopters, and electric actuators, and on, so on, so on. So there are lots of things to come. But this also brings new kind of operation, taxiing without engine running. So you have a motor in the wheel and you go on. Law of flight idle, this is the one I already explained. All electric conventional, all electric VTOL. Suddenly you can have vertical takeoff and landing at a certain place and not like a helicopter. So it's really going perpendicular up. Point-to-point transportations from airfields, and on-demand mobility from everywhere to anywhere. So this is really the future. That's the scenario. That's the vision of the people. And some cities are actually very interested in that. They are really going for it and asking, okay, what do we have to do to make this happen? So we are talking here about innovation. We are talking here about the future. We are really talking about new ideas, new things to happen. This is a very old mind map, and Alain mentioned it already. I'm doing this since quite a while. So this mind map is now 2.5 years old. I have put it in here, and I guess a lot of you have seen this already. I put it in here because it's still valid. Here on the mind map, and you can read this later on, I don't go through this now, it's really where you have all the bits and pieces from technology, philosophy, and the affected rules and this kind of thing. Have a look afterwards to that to see where electric and hybrid aviation really plays into. It's really everywhere. But remember the scene. Due to the nature of aviation, the high level of public attention this gets, if we have an accident, unfortunately we had recently one, the complexity of the worldwide network in the back, aviation is very, very regulated. It's intentionally very regulated, defined, and organized. There's little flexibility because we need to know what happened. What is this aircraft doing? The future possibilities, though, with the upcoming new technology for electric aviation, they go far beyond what we have currently in our system. And this is an area which will develop through the next years even further. Keep this in mind for the rest. So some thoughts on that. Does it fit? Do all these new concepts fit in the current regulation? Sure, not yet. So, however, we started to think about, 2.5 years ago, we started to do something. And for that, you have also to keep in mind the European perspective. It's a little bit tricky here because we have different building blocks. We have different partners we have to share the whole thing with. We are not responsible for each and everything. So we have the EASA as a competent authority for the initial airworthiness, but we have also on board the NAAs, we have on board the Commission, we have on board the countries itself, the EU member states. All this needs to go under one head. What to do? Of course, new specifications needed, new flight routes needed, especially for the on-demand mobility. We need new landing strips, pads needed. We are talking here about not heliport or airport, we are talking about vertiport. New licenses are needed because those new type of aircraft might go from piloted to non-piloted at all to autonomous. So the question is what kind of license. New rules are needed, of course, and rulemaking activities is needed. And I know that industry would like to have rules so that they have a clear target for the development, but all different kind of designs are currently done. So you have seen it at the very beginning. It's not just one type of aircraft and we can get rules for this. It's all different kind of designs. We have no fixed designs. What we find is that with the companies, they start with one design and over the time, this design even changes from completely powered lift to on wing, or from on wing to 4 persons to 7 persons. There's quite a change ongoing still in the design. We have different intended operations. We have to think outside the box because all this is new, all this was not yet so far existing. And of course, this is quite a big challenge. We are rule makers. For us, it's sometimes not that easy because we have certain boundaries we have to obey. But we want to avoid limitation of technology by too early rulemaking. You say you want to have rules so that you know what you have to do. Yes, I agree. We agree. On the other side, if we set the rules, you have to follow the rules. And by that, all innovation next to this is not possible anymore. And then we have to do, again, rulemaking. And this is senseless in the end. This actually blocks you. So we want to use the built-in flexibility, and this is what we do. For the technology, we have special conditions. Recently, there was one issued, these special condition for VTOL. And for the rules, we have derogations and exemptions. And here I want to highlight that this is only going together with the NAAs, because exemption derogations have to be done by the NAAs. It's not possible that we do them. Of course, we support, but the NAAs needs to go with us, and you. And we have then the electric and hybrid aviation project. If you have been last year here, you saw already one of this. We have reorganized this now a little bit. We have learned during the last year about communication paths and so on. So what you see here is the latest development of the electric and hybrid aviation project, where you see as a project manager Michael Singer, with 3 main areas: small aircraft, large aircraft, and the vertical takeoff and landing aircraft. And all this is with oversight by a steering committee. And the steering committee, actually the chair is our certification director. Plus, you see it here in the left picture on the right side, we have all the representatives of the rest of EASA. And this is very important. As I said before, rules are affected. And rules is within EASA, within the Flight Standard Directorate. So we need them. And of course, we have them in the box. And then on the lower side, you see the focal teams. And this gives us the flexibility. We create focal teams where we need it, as well as we say, okay, we stop this team now. So, for example, we have, because for project this was necessary, we have a team on the 1309. What do we require for vertical takeoff inside cities, into hostile and congested areas? This is was a big part of that. So therefore we created this team. Or for the special condition for VTOL, there's another team. And by that, we have, as I said already, we have quite a big flexibility, and this is what we're using. Of course, all EASA is in the back, all EASA is supporting this, and we are talking a lot with industry. On the right side is just a picture to show you that the project team itself is kept rather small to be fast in communication, to be fast in getting decisions made. And around this core team, we have the team as necessary, sometimes bigger, sometimes smaller. The actual status, and this is now new also to them, seen this presentation before. The first regulatory barrier and gap analysis has been done. So we have really checked all the rules, where are barriers, where are gaps. Most of the items for full electric aeroplanes have been sorted out, found and identified. And there we have started to work on derogations and exemptions to that, so this aircraft can go. However, this analysis, of course, it's not just you sit down, you do it once, and it's okay. You have to do this, you have to redo this for each new design. So this is an ongoing process, what we are doing here. And also for the operation, it's necessary. If you start from an airfield and you land on an airfield, aerodromes, airfield are not really affected. If you want to go to a vertiport, suddenly we have to think about a vertiport. So again, this is going on and will go on in parallel to the projects. And as said before, the special condition for VTOL has been published, the draft, and you are very welcome to have a look at that and to comment. We are really very, very much looking forward to your comments to see if you agree to the way forward we are going, or if you have proposals, or if you say, I would like to have it different, let us know. Please take the time, look through this, and let us know. The scope, the TC scope for aircraft and engine may evolve. Coming to a different subject, so far basic regulation always said for products you have to have a TC, which created the need to have a TC for a propeller, for an engine, and for an aircraft. But motors so far was not covered. Now the new basic regulation says, well, it must be certified. So you can have a separate TC, or you can do this under the scope of the aircraft. So here we have done already the first change in this direction. But do we consider the electric motor as product, as part, or can it be both? So would it be a ETSO, for example, or really under the aircraft? Under the aircraft, I said already, and the two other bits, TC, for bigger ones, this might make sense. For the intermediate ones, we are currently discussing whether ETSO might be possible or not. So it's really depending on the size and the complexity of the electric motor. If you have a small one, you can do this easily under the aircraft, because the aircraft manufacturer, especially if you use this motor for controlling the aircraft manufacturer has a big saying in what the motor is looking like. And most of the times they're actually developing this. So it makes sense to have this under the aircraft. If you have bigger ones like for big transport aircraft, then you have quite an advanced cooling system and control system and all this kind of thing. And if you want to install this to several aircrafts of different type, then it makes sense to have a TC. So you see also here we have all the bandwidth, and we are going for that. And technology is not covered by current regulations. Well, yes, true. So currently we have no for example, no specification for electric motors, but this is something we clearly can handle with special condition, what we do. Just some high-level overview over the main items on the rules. So airworthiness-wise, mainly gaps, and we can close this using special conditions. Environmental protection, mainly gaps. For example, we have no measurement or no practice, no test procedure for electric aircraft. They are very quiet, so you will not hear them really. If they're flying in a normal altitude, you measure this. So there we have to find a different solution, which would be, for example, to fly lower and then recalculate to the higher altitude. On the aircrew, gaps and barriers. Gap is if something is missing, while barrier is something where you clearly block out the new technology. So our bigger problem or bigger challenge is really the barrier. In aircrew, the gap is the question, for example, about the flight license. So what kind of flight license do you want to have? If you have a conventional aircraft, you can say that's more on gap because it's talking about single-engine piston private pilot license, for example. There you can consider, well, okay, this electric motor, we consider this in the same game, so we say it's still piston, we can use the same. While if we talk about the vertical takeoff and landing parts, it's not really a helicopter. It's not an airplane. It's something in between. There is really a bigger gap where we have to look at. And because the way the rules are written, this gap turns into a barrier. If you don't know something, it doesn't work. You cannot use it. And here we are working together for the projects we have with the national authorities really to find a solution using exemptions and derogations. And this works quite well, I have to say. The same as with operation. So far we know operation from airfield to airfield. Very rare, if you talk about rotorcraft, we go to an off-airfield landing, most of the times if it's an emergency or something like this. And now this becomes more standard, or it shall become more standard if you look in the future. So we have to think about this. There are gaps and barriers. Continued airworthiness, licenses is here the big thing, because we are talking about, for example, for a maintenance organization, you can work on this and that kind of aircraft. You can work on piston engine, you can work on turbine engine. And because of it's written in a positive way, what you can do, everything what is not written is excluded. Again, here we work with derogations and exemptions. Aerodromes, mainly gaps. We have no vertiport, but it's not excluded. And air navigation. Airspace integration, of course, is also a thing we have to talk about. eVTOL, they want to use their aircraft for short-distance commercial air transport. Due to the limitation of the electric power we currently have with the batteries, and batteries are really the big issue currently, we have to think about the way they operate. It's a short distance. Normally we have half an hour, three-quarter of an hour of reserve. This is here not really possible. On the other side, the hop that they do is typically 15 minutes or less. So there we have to look into how to do this. Corridors, NOTAMs, whatever. And major part of that are the local authority and the cities, of course, because we want to go into the cities, or the operators want to go into cities. So here we have all the partners on board again to communicate with. And acceptance and reactions of the public. I don't believe that you want to have every 15 minutes one of those vertical takeoff and landing vehicles going over your house. So here are a lot of research ongoing. What is acceptable to the public? What is not acceptable? Interesting enough, a lot of people said, "Hey, I want to step in this vehicle. Where can I go to do this? Where can I fly this?" Public is pretty much interested. So we will see. About the focal groups, the CS VTOL, what they have done, they have done a comparison of two specifications, the CS23 and the CS27. CS23, 1 year, 1.5 years ago, has been published as Amendment 5, where all the specific items of the specification has been taken out, put in a standard of ASTM, and only the objectives have been left. And actually, this step we have done has opened up a door, and the very moment after the publication of the CS23 Amendment 5, we got the first application for an electric vertical takeoff and landing vehicle. Because with this, it makes it possible. Now we have gone one step further. Because of this vertical takeoff and landing, you have some issues which are not addressed so far by CS23, which is better in CS27. And this group has now compared the two and has taken out whatever was necessary for a vertical takeoff and landing special condition. So just some numbers, they took about 80% of the existing CS23 and the rest from the rotorcraft, and all together, this merged together, is now our proposal for those vertical takeoff and landing. The other group, safety objectives, of course it's necessary to know what you have to do. If you go into the city, congested area, hostile environment, you don't want to see every day one of those vehicles coming down. So there was also quite a big discussion about which level we want to go. And CS23 allows a staggered approach going from 10 by the minus 6 to 10 by the minus 9. 27 knows 10 by the minus 9. Commercial air transport anyway is 10 by the minus 9. And if you compare the numbers, in the end you find you really have to go to 10 by the minus 9, which is the decision we have taken on 1309 or the 2500 in the CS23 area. Really, statistics is here against you, and for that we have to have a quite high level, although a lot of mitigation is coming again from the electric and hybrid aviation because of the distributed propulsion. Suddenly you can get rid of 1 or 2 or 3 of those electric motors and it doesn't matter, you can still fly. There's not a single path which makes this critical. So there will be interesting developments in this respect. EHAP and industry. Now a little bit to what Alain started already about innovation. We see, of course, the need to support, and we want to support the industry. And because it's new for us, it's new for you, maybe not that new, but at least in respect to regulation and certification. And therefore we have 3 different possibilities, 3 different ways, actually 4, but 3 which are different to an application. And of course, we would like you to come to us with the innovations, to involve us very, very early. So what we have is the so-called pre-application meetings. This is something we do since several years. In the EASA system with fees and charges, as soon as you start an application or you file an application, you have to pay every year for this work we do. And of course, this blocks quite some industry to say, well, we apply at the very late moment, as late as we can, to save the money. And to avoid exactly this, that at the very end we suddenly are confronted with issues, challenges, problems, we have this pre-application meeting, which is free of charge. It's up to 4 hours, maybe 5, no matter. And it's here at the EASA premises, so here in Cologne. And during this, the main objective is to create the possibility for EASA to gain knowledge, to have the meeting with you, and of course, for you to get knowledge on certification, to get knowledge how is the way forward. Can we identify already things which are really necessary to take on board, things which are critical, also time critical and money-wise. And this is really for specific technical and procedural discussions on a clear project. On a project you intend to certify later on. And the intent is to have at the end of the meeting a good understanding of the challenges of the projects for industry as well as for us, and to have a clear way forward. What are the next steps, of course, next to the application? If you have a project which is not really going, which is more general, which is not really going to end in an application at the EASA, we have the technical advisory contract. Oh, there's a mistake. It's not only 20 hours, it's actually 200 hours. It can be even prolonged to 300. Here, I have to say, it's charged on an hourly rate, and it's also at the EASA premises. And the main objective is, again, to create the possibility for EASA to work together with industry, and of course for industry to work together with us, and to discuss about technical issues in a more general way. So we had one 2 years ago with drones, where it was not really clear where to go. And during this TAC, this technical advisory contract, we discussed what is necessary for the drone, what could be a possible certification basis. And in the end, we had a report where it was very clear written what is the way forward, what we have to take into account. Although I have to say, in all those meetings, we do not do any commitment. This is something we cannot legally. But in the end, the way forward is there. For specific technical discussions, no commitment. And then the report at the end, the same, the way forward. And then we have the EASA Innovation Cell, which is on top of that. It's a small team, currently only 2 persons, and they report directly to the ED. And here's in the difference to the other bits. The main objective is create a dynamic innovation and sharing innovation knowledge and information across domains. We are not talking here actually about a specific project. We are talking here about a thought, a vision, a bigger picture. So it's not limited to one specific item. It's really, the vision could be, for example, how to get electric aircraft into our system in general. So this is what we're working with, the electric and hybrid aviation project. But this would fit in here, or actually it started somehow in here. And this is also to support the industry on innovation. The setup of an innovation network, we have the possibility to take everybody from EASA, like you have seen at the EHAP, whoever is necessary for this vision, to discuss about this. And those people we take from EASA, and of course from industry, whoever you think is good, you can have in the team. And this is for fostering the knowledge community, sharing of knowledge and information. Of course, it's limited. If you have some information which is appropriate data, of course, we can handle this as well. But also we encourage cross-directorate, cross-domain collaboration on innovation with industry and supporting foresight monitoring activities. It's simply good if you know what's upcoming, what the thoughts are, and you can prepare yourself for this on both sides, on industry as well as on agency area. Organization of thematic lectures on innovation, so this is to expand the whole thing in the end then. And setup of dedicated task force to develop thematic roadmap. So artificial intelligence would be one of the items which could be named here. So what can we see? What kind of innovation is possible? What scenario can we think of? And to develop in all different directions in a more general base. And there is a memorandum of cooperation on innovation. And this memorandum is establishing a formal framework for the whole bit here, to cooperate in an early stage, to really talk to industry, to talk with industry, to have all this in place so that we can work on that. And related tasks and actions, of course, the IPCs, the Innovation Partnership Contracts, workshops, researchers. We are working together also with research and, for example, Horizon 2020. But here you can see also PhD thesis, which we can support in this respect. We want to have universities more included in the whole thing, to go really more in the research, to go really more in the innovation, and exchange of experts on limited period, and training, of course. Innovation Partnership Contracts, the IPCs, they cover then the supply of technical knowledge. This is more or less the framework to work with you together on novel technologies, new business models, or new services, whatever the idea is. And again, focus on exchange of expertise on multidisciplinary scale. So it's not one item, it's not one project, it's really the scenario, it's the holistic approach here. And to address the concept development phase, the feasibility, and do not cover pre-certification task. This is important to know. This is the task, the TAC, or actually the application. So if you have something you want to certify, or you intend to certify later on, this is not the IPC, this is the TAC, or the pre-application meeting, or the application. Then, of course, we are working together with different standardization bodies. So we have about 140 standardization bodies, working groups. And the EASA is involved, for example, in SAE, ISDM, RTCA, EuroK, and others. So all different kind of standardization bodies. To mention some, EuroK, interesting for the electric and hybrid aviation, is the working group on fuel cell systems. This is quite a very active group. Then on ASDM, we are working with on the F39 working group. They take care about electric propulsion units, so the motor itself, or the whole powertrain, which is also something which is coming up regularly, or the 44.4T, which is the electric propulsion installation, which is nowadays called the power plant. And then, of course, electric propeller. Here we have a lot of things ongoing as well. RTCA, last year in December, I think it was, there has been issued the DO311A, Minimum Operational Performance Standards for Rechargeable Lithium Battery Systems. This is not completely covering the propulsion batteries for the electric aircraft, but this is already on the way on that. And then we have the SAE, the Safety Standard for Electric and Hybrid Vehicle Propulsion Battery, and the Special Condition 225, Rechargeable Lithium Battery and Battery Systems. This is the special condition which takes the RTCA document and the SAE document and puts the missing bit into it. Also the LSA from the ASTM standard from LSA is in there. So this is a combination of all what we have. So, any question? This was a little bit a fast round, but it's a super interesting thing, and we are talking here actually also, money was sometimes mentioned. We are talking here not about money, we are talking here about ideas, we are talking here about innovation, we are talking here about visions, we are talking here about very, very interesting items which might fail, but we try to do our very best that it doesn't fail and that we find a solution for the future to have this really incorporated in aviation. Some people are talking about this like a new revolution, like the turbine, when the turbine came in, and there's the potential for that. It's super interesting if you work in this environment, the spirit of the environment. It's really, really very tempting. You want to go. So hopefully a lot of you think the same way. Innovation, again, it's not about money, it's about seeing the future, it's about creating the future. And this is what we want to do with that. Thank you.
Thanks, Manfred, for this interesting presentation. We got a number of questions. One is particularly to the special condition on VTOL, mentioning that the comment period due to the complexity of the nature is maybe too short, and whether we would extend that comment period. Do you know whether this was discussed already?
Are you going or shall I?
Maybe I will help you, Manfred. Yeah, we considered it, but we have a dilemma. We have some real projects ongoing, and the applicants are desperately waiting for the special condition to be frozen. So we have to bear this in mind. So we would understand that for such a new special condition, you would like to have a bit more time to go through it and bring your comments. Now, just to be a bit on the safe side, this special condition is based on CS23 Amendment 5. Basically, I would say, not being over optimistic, 80%, Manfred, I would say, more or less.
80%, yeah.
And the differences are very well highlighted. So to comment on this first draft generic special condition, which is only 27 pages, I think, so you did a pretty good job.
About this, it's not too long, actually.
Yeah. So we believe it is still feasible. It deserves a bit of effort and the dedication to the task, but extending the consultation time beyond the usual 4 weeks for us would be a problem, not of principle, a bit, I have to be honest, but more important, a problem because it would impact our certification project, which are ongoing, and where I have to admit, sorry Manfred, we're a bit late in confirming our certification basis. So you see our dilemma here. So we would appreciate your understanding in trying to comment within the 4 weeks. And in any case, there will be still room for discussion because it is not the end of a process, it is the start of a process, and this will keep us busy for quite some time.
One word to that, in addition, in the special condition you find different shades, and one shade is used for the text which is already existing in the CS23 Amendment 5, and the other shade is used for the new bits and pieces. And if you concentrate purely on the new bits and pieces, this will help you dramatically to save time. Of course, if you find the one or the other misbalance, or you say here and there we should change as well, you can do this. But in the first go, please concentrate really on the new bits and pieces in there. And this makes the whole life easier.
We have one question, a bit more of a generic nature. Is the pre-application meeting, technical advisory contract, or even IPC limited to GA or available to others? So the reply is very clear. Our TAC, IPC, pre-application are available to all kind of activities. It is not GA specific. We started with GA because there was a need, but without disclosing any confidential information, we are even considering contract with the industry outside of the aviation community, if necessary. So fully open, and you are all welcome. If you feel a need for an IPC, a TAC, or a pre-application meeting, pre-certification meeting, just let us know. If we have some common interest in moving forward, we will find a way to do it. So now the difficult questions for Manfred.
Okay. The next question is a bit more technical. It's again on the special condition from VTOL, and it's about a bird small drone strike requirements planned, especially for autonomous piloting urban airborne vehicles. Anything on that, Manfred?
Well, if you look at the VTOLs you see here, they have all distributed propulsion. They have all several motors with propellers or fans. And of course the question here, because you go into the city where you have quite a lot of flocking birds and this kind of things, what do we consider for bird strike or for the new technology, the small drones, which might be also one of the issues. Here we are currently discussing on the project level. So the special condition is really a high-level requirement, while on the project itself we are discussing exactly those details. Do we take a 4-pound bird? Do we take several small birds? Do we take flocking birds? For that, it's depending also on the design and the way of operation. If typically the bird doesn't want to hit the aircraft, also the drones doesn't want to hit the aircraft. So if you fly slow, then typically a bird strike or a drone strike is not an issue. While if you then go to a higher velocity, then the bird strike is more likely because they cannot escape sometimes. On the other side, this brings now the situation that it's really depending on the design itself. If you have protected propulsion systems, for example, or if you have more open rotors and this kind of thing. So we are discussing all this, but really on the project design itself. There is no general answer, yes, you have to shoot a 2-pound bird on the whole issue or not, on the whole aircraft or not. It's really depending on the design. The design is so different every time. We see some consolidation, though, but still the designs are very, very different, and they are different prone to bird strike. The next bit, by the way, is icing and hail and this kind of things. So this is also a subject we are discussing on the project itself.
Any questions from the floor? It's not yet time for lunch, huh? You have to wait a few more minutes. Okay, we got 2 more questions. One is about the Innovation Network, how the lectures will be announced in the web shop. I don't know whether you're aware of or not about the Innovation Network and making available some of the discussion.
That's about the lectures of the innovation cell, I guess. And we have started already, also this maybe 1.5, 2 years ago. We have the possibility of different items. We do, for example, a roadshow for licenses, for operation, this kind of thing. So we can do also a roadshow for new innovation, for new innovative items, for scenarios. Of course, we can do also lectures here in-house, that we have people standing in front and giving you the latest information. I have to say, I'm currently not now aware of one lecture which is planned for the next bit. I know that we plan, for example, a workshop for the electric and hybrid aviation. Normally, this should have been here in November, but this was too crowded then with all the rest. So we plan this workshop, a very small one with a maximum of 80 people on board, because otherwise it's too big and it will not lead really to a concentrated result. Next year, early next year, in the first quarter of next year. And of course, those are different means to bring the knowledge and to discuss about knowledge, to discuss about innovation with industry, to EASA and to industry. It's really a share than what we intend. If this answers your question.
In the continuity of the previous one, there is a question. Innovative projects, by definition, are on a concurrential environment. How EASA and network will guarantee confidentiality and protection of rights? That's a very relevant question, and that's good to clarify. We've signed already a few IPC, Innovation Partnership Contract with Industry, and our legal departments, be it ours or the stakeholder, have found the right wording to have the right clause of confidentiality, of protection of property, intellectual property, etc. You should know that we are bound, EASA, as an EU agency, to some very strict rules for confidentiality. So we have all the mechanism in place to handle this in a safe environment. We are really taking this very seriously. It is also part of what we discussed before in terms of security and safety of information, how to guarantee that whatever we discuss with you remains between those who need to know about it only. So if you ever see a draft text of IPC, you will see that lawyers, be it agency lawyers or industry lawyers, have spent quite some time in finding the right wording to protect your interest and therefore our interests as well. So no problem here. Just to clarify, because the question is a bit, could be misleading. The innovation network is not the one managing, leading, organizing the contracts. The network is really a reservoir, a community within the agency we want to develop, in which we will pick up people for projects on a case-by-case basis. The one managing innovation, as Manfred mentioned, from a negotiation standpoint, are the person into the innovation cell, supported by other focal points in the directorates.
Any last question from the floor? Yes?
Yeah, one.
Yeah, Dennis Santamaria from Eurocomposite. Just on bird strikes, just some information that we are all concerned about bird strikes. For your information, there are 130 bird strikes this year, of which 25% hit the engine. So for just a message to you that to take bird strikes very seriously, to make the engine more resistant to bird strikes, but more importantly, if there is a device that will actually drive the birds away from the engines, that will be even more appreciated. It's just a message. Okay.
Thank you for that. And actually, we take it very serious. That's the reason why we have quite some discussion on the bird strike scenario and what to do with that. It's engine, of course, but it might be, if you use the engines also for control system, it might affect control system and all these bits and pieces. So thank you for the comment, and yes, we will do this, and we do this.
Okay, thank you very much, Manfred, for this
Thank you.
presentation and for answering all the questions.